All right, so here we'll be looking at the exercises, which is the fourth video for this section. Now, if alpha is 575 and theta is minus 11 pi over 6, if both of them are angles in standard position, then which one of the following statement is true about the location of alpha and theta? So since they are in standard position, they will be in the same terminal with their coterminal, right? So I think the best thing is just find the coterminal. This is if you have alpha. So let's find the coterminal for alpha. The coterminal for alpha will be 575 degree plus minus K 360, right? So here now, let's just use minus because we want to make it to be between 0 and 360. So, and if you take K to be 1, which K equals to 1, you can see you have 575 minus 360. And this would give us about, let's say, is it 215, right? Yes. So I think this will give us about 215. And if you have 215, this will be in which quadrant? So we have 215 degree. And we know that 215 is going to be in the third quadrant because it's bigger than 180. So it means alpha should be in the third quadrant. This is in quadrant 3. Okay. So similarly, we go for theta. Just we need to find the coterminal of this. So to find the coterminal, this is the coterminal. So I'm dealing with what? Let's take theta to be minus 11 pi over 6. If I want to find the coterminal here, the coterminal will be minus 11 pi over 6 plus minus K2 pi, right? But we want to make it positive, so we have to use plus. So you have plus K2 pi. So if you take K to be 1, with K equals to 1, we're going to have minus 11 pi over 6 plus what? 2 pi, which we can write as what's as 12 pi over 6, right? That's when K is 1. And you can see that this will give us what? Pi over 6. Yeah, and we know that pi over 6 is in which quadrant? Pi over 6 is in the first quadrant, right? So this will give us pi over 6. And we know that pi over 6 is in quadrant 1. All right. So I think, yeah, our answer should be quadrant 3. Is it D? Quadrant 3 for alpha, and theta quadrant 1. Yeah, because pi over 6 is what? It's about 30 degrees, which is quadrant 1. All right, so let's move to number 2. Number 2 says, if alpha is the smallest positive coterminal of this. So let's try to get alpha first. We know the coterminal to this number is going to be, this angle is plus minus K 360 in this case. But if we are looking for the smallest positive, I think we can get that. If you take K to be 1, it will not work. If we take K to be 2, also, if you take K to be 2, it's not going to work because you have 720, and this is 7 So I think we have to take k to be 3. This is 3 times what? 360. 3 times 360 is going to be, I think, 1080, right? Yes, and this is when we take k is equals to 3, right? So we have this. And now what can we do here? We have to check this one. So is this going to be positive? Definitely yes. So we have minus 743. If you add 1080, we're going to have, I think, 337 degree. So this is positive. So this is going to be our what? Because this is going to be our alpha. So we take alpha to be 337 degree. This is alpha. In the same way, we find beta. What is beta? Beta is also the smallest positive coterminal to what? 360, right? So since this is 360 already, the coterminal here will be not 360, 610. Here we have to minus K360. So you have 610 minus, if we take K to be 1, I think it's fine. Can we take K to be 1? If we take K to be 1, we will have 610. Let's take K to be 1. So this becomes 360, right? So what do we have? We have 610. We're subtracting 360. So this is giving us what? 250. Yeah, so this is fine because it's less than 360. So we can take our beta to be 250. This is using K to be 1. So for beta, we're using K equals to 1. For alpha, we're using K is equals to 3. So it means that alpha minus beta is simply 337 minus 250, all in degrees. And this is nothing but what? 87 degrees. Now, the greatest negative angle, so this is similar. Here we are looking for the greatest negative angle that is coterminal. So we have 227 pi by 5. Now, since you want negative, you use minus k 2 pi. Then we have to start testing the k until we get what's negative, right? The first negative. So for example, if you take k to be 1, we're going to have 27 pi by 5 minus 2 pi, which we can write as what's, this is 5. So you have 2 pi. 2 pi we can write as 10 pi over what's over 5. You see, this is definitely positive, right? Because this is going to be 17 pi over 5. And we can see this is greater than what? This is positive. So we can take it. Now we try k is equals to 2. We'll have 27 pi over 5 minus, if k is 2, it means we're dealing with 4 pi, right? We're dealing with 4 pi. So 4 pi, we can write it as what? 27 pi minus 20 pi all over 5. And this is going to be 7 pi over 5. This is still positive, so we cannot take this one. Now we can take k to be 3. So let me put the k's here. So this is k is equals to 1. And this is when k is equals to 2. So let's try k is equals to 3. If k is equals to 3, we will have 27 pi over 5 minus what? 6, right? Minus 6 pi. And what does that mean? This implies you have 27 pi over what? 30 pi over 5. This is just minus 3 pi over 5. You see, this is less than 0. So this is the first one, and that is the one we can take. So our answer is A. Is A. Now, number 4, which one of the following is not coterminal? It's not coterminal with what? With 50 degree. So all you need to do is you remember your what? Your definition of coterminal. What is the definition of coterminal? Coterminal simply means that what? If you have coterminal, you have theta. So what is our theta now? Our theta is 50. So plus minus k of what? 360, right? So you just have to see which one will not give you. It cannot be found here. For example, you see, if you take k to be what? If you take k to be 1, it means your coterminal is what? 50 plus minus what? 360, right? This will give you two values. This will give you 50 plus 360, which is already what? 410. Or what? 50 minus what? Minus 360. This is going to give you what? Minus 310, right? So already you can see that this 410 is a coterminal, and also what? Minus 310 is a what? Coterminal. This you get when you take k to be 1. Now, if we take k to be 2, what do you get? You see that coterminal will be 50 plus minus 2, 720, right? Now, what does this give us? Here you will get what? 50 plus 720 is going to be 770, right? Then 50 minus 720 is going to be what? Minus 670. So you see, this is a coterminal. And what is also a coterminal is what? 770. Right? So you can see the only one left is what? Is 230. Definitely 230 is not a coterminal. So this is one way to quickly eliminate which ones are coterminal, and you can pick the one that is odd out. So 230 is not does not share the same terminal as what? As 50. And as you can see, even if you go 360, if you subtract from here, you will not get 50, no matter the k. So B is the answer here. Now, the arc length that subtends on central angle. So the central angle here, theta, is 100 degree. So it's okay. We can take it to what? We can take it to radian. So this is 100 times what? Pi over what? 180, right? So this would cancel. You can divide both sides by 2. So I think this is just 5 pi over 9 rad. Yes, just 5 pi over 9. 5 pi over 9 is fine. Okay, the arc length that subtends a central angle. Okay, so we're looking for the arc length. And the radius is what? The radius is going to be 36 divided by 2, because 36 is the diameter. So this is 18 centimeter. So we will use S is equals to R theta. R is 18. times 5 pi over 9. And this is going to be 2 times 5 pi. And this is just 10 pi. And this will be in centimeter. Number 6, the length of an arc that subtends the central angle of, is it 9 degrees? Okay, so theta is 9 degrees. And this is simply 9 times what? Pi over 180. And this is simply pi over 20. All right. And what is the radius? The radius is 20 centimeter. So the arc length S is equals to r theta. And this is just 20 cm multiplied by pi over what? Over 20. And this is just going to be pi centimeter. All right, so here is talking about so here, if a point on the edge of a wheel of diameter 20 centimeters, so here the radius is going to be 10 centimeter, right? And rotating at 80 revolutions. So omega here is 80 revolution, the angular speed per second, right? Then we're looking for what? We're looking for the linear speed. So we're looking for V, which we don't know. So what do? First of all, we convert this 80 revolution per second. Let's convert it to radian. We multiply by 2 pi rad over 1 revolution. So this is going to be rev will cancel rev. So this is going to be 160 pi rad per second. Yes. And we're done. So V is just R times this. R times the angular speed. And what is R is 10. So you have 10 times 160 pi rad per second. But just like I explained earlier, let me explain it again. Some people might like, okay, why is this rad going away? Because R is what? R is 10 centimeters. So you have 10 centimeter multiplied by omega, which is 160 pi. You know, you see rad, and there is a second, which I can put here. But this centimeter is actually, in a way, going to be centimeter per watt rad. Because I explain it, because you have this one, right? So your R is just S over theta. So if the unit of S is centimeter, the unit of theta is rad, right? So in the reason the radius is supposed to be in centimeter per rad. So, but we just write centimeter. So that is why you see this and this will go. Our final answer, there's not going to be rad. It's just going to be 1600. There is a pi, there is a centimeter, and there is per watt per second. So we have A to be the answer. Number 8, a tire rotates 240 times per minute. This is also talking about the rotation, 240. So it means it's talking about 2 revolution per minute. So you're looking for through how many degrees does a point on the edge of the tire move? So now you have T is equals to what? Half second. So now we are looking for theta, right? Because you want to see how many degrees it moves. So what can we do here? To find theta, we know we can find theta easily if we know the what? If we know the angular think if we know the angular speed, right? So let's see, we already have the angular speed here, but now let's convert it to radian as usual. So this is 240 rev per minute. Since we have time in second, we also convert this to seconds. So this would be times 2 pi rad over what? 1 rev. Then I will multiply also here by 1 minute over 60 seconds. This is because I want to change to rad per second, right? So here you can see this will go with this. And we have what? 2 times this. So this is like, is it 480? Okay, let's just write it. This is 240 times 2 pi rad. Now, divide by 60 seconds. So let me just go down. 2 here. 2 into 60 will be 30, right? And 30 into 240, this is going to be what? It's going to be 8, right? So everything is just going to be 8 pi rad per what? Per second. So this is our omega. Now, what do we know about angular speed? Omega is theta over t. So theta is going to be omega times t. So omega here is 8 pi rad per second, right? And now you have to multiply by what? T, which is half. So everything is going to be 4 pi theta. But this 4 pi is in what? It's in radian. But the question is asking that what? How many degrees? So we have to convert it to degrees. So this is 4 times 180. And this is just going to be 720 degrees. All right. Okay, so let's see 9. It says the tire of a bicycle have a radius. So the radius is what? 26 centimeter, and rotating at the rate of omega is 250 revolution per minute. So now we want to find V in what? In kilometer per hour. So this is what we need, V in kilometer per hour. So here we have to make some conversion, right? Okay, so let's start with omega. Omega is what? 250 rev per what? Minutes. Now I will multiply by what? We'll just multiply by 2 pi rad over 1 rev, multiply by what? Let's go to hour. Right? Let's go to hour. So to go to hour, we know that what? 60 minutes is what? Is 1 hour, right? So it means we have to multiply by what? 60 minutes, and then we have 1 hour here, right? So this is going to be 1 rev, we'll go with 1 rev. So here now we're going to have this times this is like 500 times what? Just 60. Let's leave it for now. Pi, and this is going to be rad per what? Per hour. So this is our angular speed. All right, angular speed. Okay. So here we need to find V, but what is V? V is R times omega. So this V is now 26, but this is 26 centimeter. Since we need it in kilometer, because we need our speed in kilometer, so you have to change centimeter to meter. It means we have to divide by 1,000, right? So this conversion is to change, because we know that what 1 centimeter, 1 kilometer, right? 1 kilometer is the same as, let me write it here, 1 kilometer is the same thing as 1,000 centimeter. So to do that conversion, you have to multiply this by what? 1 kilometer over what? Centimeter. This is, you have to do it. Then multiply by our omega, which is just 500 times what? 60 pi rad per hour. Then we just need to cancel here. So let's do the cancellation and see. Here already, this is how many zeros? 3 zeros, right? So this is 3 zeros. Did I miss anything? This is 26 to 5 revolution. So we have per minutes, beating. Oh, okay. So let's see. 0 will go with 3 zeros will go. And 3 zeros will go, so we are left with 26 times 5. We're looking for the speed of the bicycle. Let's see, per minutes. Okay, let's see what is happening here. All right, so I think, no, here, this conversion factor is not correct. If you have 1 kilometer, right, it's actually the same thing as 10 to power 5 centimeter. The one I did, if you have 1 kilometer, is 10 to power 3 meters. Yes. So here we are to divide by 10 to power 5 because we want centimeter to kilometer. So this is 10 to power 5. Right, this will be the right conversion factor. So in that case, so let's do away with this. This is 500. This is coming from here. This is 500 times 60, remember? Pi rad per hour here. So let's see how we can cancel here. So this is 10 to power 5. So I can write it. Let me just write it power, so that we know that these 3 zeros will go with what? Will go with this 3. So it means we just have 26 times what? Times 5 times what? 6 divided by 100. Is that okay? All right. So now what can we do about this? We can take 5 here again, and 5 here will go 20. And that means that you are left with 26 times 6 divided by 20. Then we can go here with 2. Here will be 10, right? 2 here will be 3. So we have 26 times 3 over 10. And then we can go with 2 again. 2 here is 5. 2 here is 13. So we have 13 times 3 over 5. And don't forget, we have pi somewhere here. The pi is always there. So we have 39 pi over 5. So here, this is what to note. These are conversion factors. 1 kilometer is 10 to the power 5 centimeter. 1 kilometer is 10 to the power 3 meters. And we need that for this question. All right, so number 10. You say if a belt runs a drive wheel of radius 8 centimeter and the revolution is what? Omega is what? 15 revolution per minute. Then you want to find V in what? In centimeter per second. So here we just need to change omega to be 15 rev per minute. We have to multiply this by what? By 2 pi rad over 1 rev. Now it's better to take everything to second because you are looking for centimeter per second, right? So it means we have to multiply this by 1 minute. We divide by what? 60 seconds. So this will give us 15 times 2, 30 pi, because rev will go with rev. So you just have 30 pi rad. And everything you divide by 60 seconds. So this will just be pi over 2 rad per second, right? Now, pi over 2 rad per second is our W, or our angular speed. So the linear speed is just going to be R times this. And what is R? R is 8. 8 times pi over 2. This will just give us 4 pi. But this 4 pi is actually in what? Centimeter per second. All right, so I think that is the solution for the exercises. If you have any questions or any comments, you can put it in the comment section. Thank you for watching. And if you have not yet subscribed, kindly do that and share this video. If you find it interesting, share it with your friends.